In this section, we're going to be solving inequalities with variables on both sides. So let's start with an example. X is less than 3x plus 8. We see that we have some like terms, x and 3x, so we want to combine them before we start isolating the variable. So we're going to subtract 3x on both sides. X minus 3x would give us a negative 2x less than positive 8. Now we want to isolate the x. In order to do that, we must divide both sides by a negative 2, because negative 2x divided by negative 2 leaves us with 1x. But when you divide the 8 by a negative 2, the sign in the middle must be flipped because it was a negative number. So x is greater than negative 4. And we can graph this on the number line, starting at the negative 4, put an open circle because it's just greater than, not greater than or equal to, and then the line extends out to the right. Now we're going to look at another example that requires a little more simplifying. Negative 0.8x plus 0.9 plus 0.6x is greater than or equal to 1.6x. We see that we have some like terms, negative 0.8x and 0.6x, all on the same side, so we can start off by adding them together. When you add those two terms together, we get negative 0.2x plus 0.9 is greater than or equal to 1.6x. Now we want to move the 0.2x to the right side. In order to do that, we must add 0.2x to both sides. When we add 0.2x to the left side, it becomes 0. When we add it to the right side, we get 1.8x. So we now have 0.9 is greater than or equal to 1.8x. Now we can isolate the x by dividing both sides by 1.8. When you divide the right side by 1.8, you get 1x, and then when you divide the left side by 1.8, you get 0.5. So we have 0.5 is greater than or equal to x. And if we read it the other way, x is less than or equal to 0.5. So let's find 0.5 on our number line. Put a dark circle because it is less than or equal to x. And because it's less than or equal to, the arrow is drawn to the left. Alright, now we're going to look at an example for all real numbers as a solution or no solutions. So basically we have x plus 5 is greater than or equal to x plus 3. In this problem, we can see that if we moved the x to the opposite side, both the x's would cancel each other out. So in this problem, x plus 5 is greater than or equal to x plus 3 we can see that it's in all real numbers will work, because no matter what number we put in place of x, so for example if we put 2 plus 5 is 7 and 2 plus 3 is 5. So no matter what number you put, the left will always be greater than or equal to the right.